Okay, now that we've covered two different types of sensors, and you guys probably have enough background that you can extrapolate that into other different types of sensors, especially looking at different references and resources that you can find on the internet, or through whatever sources you're looking at. If you have text or discussion with your colleagues through the discussion boards, let's move on to actuators. The first actuator we're going to talk about is the servo motor. And a servo is a kind of a convenient form factor because it actually has a controller built into it. And if I hold this up like that, you can probably see that there's a little chip inside there. So inside this little box, there's actually a motor, a set of gears, so you can see the gears right there, as well as a position sensor. And so that position sensor is able to tell the motor whether or not it's at the desired position sent to it and then adjust it. These are also very, very small motors, at least in this one, very small motors. And so we can power these usually directly from our Arduino itself. As you go to bigger form factors of servo motors, you will need a separate power source to power them, but you can still send them the signal along just one pin on your Arduino and just have a separate isolated power source for the power on these, which is convenient, right? So usually on these, if you look at them, they have three wires. The brown wire is usually ground. The middle wire is usually the power source, basically the voltage input, and then my right, your left, the yellow line here should be the signal pin. Another thing we're going to talk about today is using libraries to help make it more convenient for us to control different components. So we're actually going to try using the servo library. Before we do that, let's take a look at what the servo library looks like. So if I go on to the Arduino website and I search for servo, it brings me this breakdown of the servo library page, and it describes servos a little bit. Again, here a description of the power, ground, and signal wires that we just looked at. And then also some examples of how you can use the servo library to perform different operations, right? So here's control the position of a servo with a potentiometer, and there's sweep the shaft of the servo back and forth. Since we have a potentiometer in our circuit, let's go ahead and look at the knob example where we use this servo with a potentiometer, right? Again, a breakdown of how to wire up the circuit. We have a potentiometer here. They're sending their potentiometer to analog A0, which is convenient for us because that's how we have ours wind up. And they're using pin 9, which we've already using, but we can use a different pin to control the position of the servo. So we'll just modify this just a little bit. You can see here we also have the power and the signal lines described as previously. Here they have black, red, and yellow. We have brown, red, and yellow, but you can see that that's pretty similar to our setup as well. Um, Also, an important thing to note on this is that we have a servo horn, which I've put on here just by pressing it on. And these kind of pop on and off pretty easily. They have a screw that can go into the middle of the servo output to help hold that on. If you don't need to have that on there, you're not using it to hook things up, I would leave that screw out just because it's easier to take it on and off. And unless you're going to be driving something with this where you need it to stay in place, I would wait until you have the position set up kind of where you want them before you have this, because it's going to have a limited range of motion. And so if you build your circuit all up together and you basically build your entire thing and you figure out that you need it to start 5 or 10 degrees in one direction or the other, it's easy to pop it off and put it back on. And once you've got kind of your system all figured out, then put the screw in so it stays in. So I'm not going to bother putting the screw in just to save time. All right, so let's wire this thing up. Let's take a black line for our ground and let's use yellow because it's closer to what they have for theirs. A yellow line for our signal, and let's get a red for our power. All right, so I've got my 3 cables here. So again, I'm going to use the same power lines I have here on my board. So I'm going to do red into that middle red pin, my black into that brown pin. And if you see they get stuck in there, just make sure you get it in straight, so that way you don't push out these pins. You can push out the metal inserts in here out through this adapter. And if that happens, just put it back in. It's not that big of a deal, but every time you push them out, they come out a little bit easier the next time. So you gotta be a little bit careful about not pushing too hard on those. Just make sure it's kind of in the middle of it and not just kind of lined up. All right, so the power is set up, and then I'm going to take my signal pin. I got to figure out which pin I want to use for my output. I'm going to go ahead and use pin 7 since it's opened. So I'll put that into pin 7. All right, so very easy to wire up. Again, we have just power going to the system. It doesn't have to be the power from Arduino, but I think this one is small enough it won't be an issue. And then we have our signal pin, which we're going to use to control the actual servo. Now, if we look back at our library, if we want to include a library in our code, we need to add this to the header of the code space. And so if we look at our example here, they have a copyright thing here saying who wrote this out. They have include, and then in these greater than, less than brackets, they have servo.h. That servo.h, that's the actual library that you're adding to this. And so if you don't include that, the servo functions that you're losing later on in the code won't work. So I'm just going to put this down here. Oh, sorry, I want to include first. Let's copy this out. Hashtag include servo.h. And then I want to define a new servo, just like they have here. So that's creating a servo object inside my code, right? So creates a servo object. And if you have multiple servos, you want to give them different names. So you can have servo 1, servo 2, servo 3, etc., etc., etc. But again, we already have a pot pin, and we have different values that we're using there, so we're going to mess with those. I do need to attach my servo to the appropriate pin. So down here, I'm going to put in my servo dot attach. Again, the my servo, that's just the name of whatever servo you're trying to attach the pin to. So I'm attaching this to my pin 7. If I wanted to specify a servo pin, I could do that as well. But since I'm going to be referring to this using the my servo name rather than the actual position of the pin, then it's fine. And in the code here, you notice all they're doing is they're doing myservo.write and then val, where val is a mapping between 0 and 180. So that's the position. And they're mapping that out using 0 to 1024 from the analog read. So if I go back to my code here, if I want to read the pot position, I can add that or uncomment that, right? And then down here, or even put it right here if I want to. I can say int angle. Yeah, James, I'm in a meeting, sorry. Sorry, that was my son. And we're going to set that angle to map. And again, the map here is going to take the input of my pot position, just like they're using val in the example there. And it's going to transform between 0 and 1023, right? That's the input range, to 0 and 180. Now this is basically the same thing if I had divided pot position by 1023 and then multiplied by 180. So it's just doing a conversion for me. And on this kind of thing, it's not, this math is pretty easy. It's not that hard, but it's going to save you from basically making mistakes if you're using this kind of function. You can also use this to be a little bit more efficient in terms of how you're doing the codes. This is actually computationally easier than doing several steps of math. All right, so that gives me my angle, and then all I need to do is I need to write that angle to my servo. And let's try running that and see if it works. So I'm going to minimize this so we can actually see our system. And then I'm going to plug in my Arduino. and then I'm going to upload the code. Now they had a delay in theirs as well. Oh, here I was messing around with some other components and I forgot to take that out. Let's try that again. Again, more of just things that I had written for other lectures. All right, so it's uploaded. So now when I turn the potentiometer, you see the servo tries to move to match the position. You know, it's a little bit jittery just because, you know, for one, it's not that accurate of a system, and it has to overcome its internal resistances. So it kind of doesn't really move until it gets to a large enough value to get to that. And so there's some jitteriness there. If I move quickly, it's got enough of a lag where it doesn't kind of catch up and then stop and then catch up and then stop and then catch up and then stop. So anyways, so that's how you use the servo motor. Pretty easy component.